Alright, welcome to the video on section 1.5, radical equations and absolute value equations. A radical equation is just something that involves a radical sign. So if you have a square root of x, for instance, a simple radical equation would be the square root of x equals 4. Right, so what are the solutions to that problem? To find it, you would just square both sides, right? And you would get x equals 16, right? So x equals 16 is a solution. We could graph it. So y equals square root of x. And then I'll also graph 4, right? So y equal 4 should just be a horizontal line. And I know the answer is 16, so I know I'm going to need to see out to at least 16, so I'll go up to 20, just make sure I can see it. So there's the radical equation. There's 4, and you can see where they cross. Second trace intersect. Inner. And you see that x equals 16 when y is 4. Alright, so that's an example of a radical equation. You have to be careful whenever the radical is out here is the index, right? So if there isn't one, we assume the index is 2 for square root. Otherwise, there should be a number out there. When there's an even index out there, you can get extraneous solutions. So you need to make sure you check your solutions back into the original equation to make sure they work. I'm just going to work some problems on page 134, and I'm going to work the ones that are highlighted. So let's start off with number 11. See the square root of 2t minus 1 equals 1. Alright, so we have a radical over here, we have a number, so what I can do is just like I did up here, I can square both sides, right? Square that, square that. When I square it, I get rid of the radical, and it's just 2t minus 1, and 1 squared is 1. So then 2t is going to equal what? 2, right? Because I add 1 on both sides, and therefore t is 1. So it looks like the answer is 1. If I plug it back in, I get 2 times 1 is 1, minus 1 is 1, square root of 1 is in fact 1. So it does work. Alright, number 23. Square root of 15 minus 2x equals x. Okay, so I've got a radical over here and an expression over here. So to get the idea is you got to get rid of the radicals to solve. So I need to square both sides. When I square this side, I get 15 minus 2x. And when I square this side, I get x squared. And that's going to give me an quadratic equation. So I'm just going to bring everything over here. Alright, so 0 equals x squared, and then I'm going to bring that 2x over, so I add it to both sides, it'll become a plus 2x. And I'll subtract that 15 from both sides, it'll be a minus 15. And that might factor, let's see, two numbers that multiply to negative 15, but add up to 2, negative 5 and 3, right? X minus 5, x plus 3. So when you add those, you get, oh, nope, wrong way. This has to be plus. And this has to be minus, because when you add them, you have to get positive 2. But when you multiply them, you have to get negative 15. Alright, so the solutions to this then would be negative 5 and positive 3, right? So x equals negative 5 and x equals positive 3. But I don't think the negative 5 is going to work. I think it's extraneous because when you take the square root of something, you're not going to get a negative, right? So I think when I put a -5 in there, let's see, what do I get? So 15 minus 2 times -5, that's 25, and the square root of 25 we say is 5, not -5, right? So, but 3 should be fine because it's positive. So if I put a 3 in there, that's going to be 15 minus 6, and 15 minus 6 is 9, and the square root of 9 is in fact 3. So that one works. Now let's graph it and see that the solution is in fact only 3. So I'll make this, we're going to graph both of these separately. So this one's just going to be x, and this one's going to be the square root of 15 minus 2x. Graph. Alright, so and you can see there's only one intersection. And you get 3. So -5 is extraneous. Alright, 31. The square root of 3x plus 1 minus the square root of x minus 1 is 2. Alright, in this one we've got 2 square roots, right? So the idea here is we're going to have to isolate one of them, square it, and then we're still going to have one, and we're going to have to isolate it again, I think. So before I start, let me just see what this graph looks like. So square root of 3x plus 1 minus the square root of x minus 1, and then I also want to graph 2. Interesting graph. Looks like there's one solution. So it looks like the solution is 5. Alright, so what I'm going to do first is I'm going to isolate one of these. I'm going to isolate this one. So I'm going to take this one over here with the 2. Alright, so square root of 3x plus 1 equals 2 plus the square root of x minus 1. Alright, now I have to square both sides. Well, squaring this side's no problem. That's just going to be 3x plus 1. But when I square this side, I've got to FOIL that out, right? I've got to distribute correctly. So it's going to be, what I'm doing is really 2 plus the square root of x minus 1 times 2 plus the square root of x minus 1 again. So let's see what I get. So 2 times 2 is 4. 2 times that is 2 square roots of x minus 1, and when I do this I get another, so that's a total of 4 square roots of x minus 1. And then that times that is just x minus 1, positive x minus 1. Right? Okay, so now I've got another square root, and I have to isolate that and square again. But first I can simplify here. So what do I have? Well, I've got 3x here, and I've got x over here. So I'm going to bring that x over here with that. Give me 2x. Alright, and then it looks like, so that's gone. Now I've got a 4 and a minus 1. So there's a total of 3 over here, right? So I'm going to take away that positive 3 from both sides. And that'll give me, what, if I take away 3 here, I get minus 2. What I'm left with is that 4 square root of x minus 1. Alright, and since you don't have to do this, but since everything is divisible by 2, that's divisible by this, then I might as well go ahead and make this a little simpler. So I'll divide this by 2 and get x, divide that by 2 and get 1, divide this whole thing by 2 and get 2 square roots of x minus 1. Alright, so this is what you can leave it there. It's probably easier just to leave it there when I square now. So I'm going to square again. So now when I square, I'm squaring x minus 1, which means I've got to do x minus 1 times x minus 1. And that's going to be x squared minus 2x plus 1. You can multiply that out and see for yourself. And this is going to be 4 times x minus 1. So I squared that, got 4, squared that, I got x minus 1. So I have x squared minus 2x plus 1 equals, distribute, 4x minus 4. Last thing I need to do before I start solving for x is bring everything over so that it's all equal to 0. So I have x squared, I'm going to bring over that 4x, so minus 4x from that is going to be minus 6x. And then add 4, so that's going to be 5 equals 0. So that should factor. Two numbers that multiply to 5 but add up to negative 6 are x minus 1 and x minus 5, right? Because when I multiply those, I do get positive 5, but when I add those, I do get negative 6. Alright, so my two solutions are x equals 1 and x equals 5. Are any of them extraneous? Right? Well, obviously, yeah, it looks like this one is extraneous. Why is that? Or is it? Maybe I just didn't. I bet maybe it isn't. Maybe I should zoom in on this and see what's going on. So let me zoom in right here. Up, so my window, I'm going to go back to 0. Because if it crosses, if this is not extraneous, then it crosses at 1. Yeah. As you can see, there's that little gap right there, right? So it's pretty close, but unless there's something going on with this picture, it looks like 1 is extraneous. So let's plug 1 back in here and see if it works. So I'm going to check x equal 1. So the square root of 3x is going to be 3 times 1, right? So 3 times 1 plus 1 minus the square root of 1 minus 1. Does that equal 2? That's the question. So that's going to be 4. Square root of 4 minus 0. Yeah, that seems to work, right? So square root of 4 minus 0 is 2. So it's not extraneous, but I don't see that it's showing up here. It's really interesting. I can also go to my table, and when x is 1, I do get 2. And when x is 5, I get 2. So it's tricky. Those are both equations. So be careful here. I guess that's a lesson to be learned, that your calculator doesn't always show you a picture that makes it look like a real solution is in fact a solution. Alright. And I'm sure 5 works because it obviously crosses, so I'm done. So these are both solutions to this equation. Alright, 51. So 2 times s plus 1 squared minus 5 times s plus 1 equals 3. Alright, so this is kind of a separate deal. There's this trick that you can use in situations like this where this is not a quadratic equation. Well, I guess if I were to expand it out, it is, but it's already in the form of a quadratic. By this, what I mean is, if I were to just to make a little quick substitution, so for instance, pick a letter, let's say W. I'm going to let W stand in for S plus 1 temporarily, right? So this would become 2W squared minus 5W equals 3. So you see what I mean? It's a quadratic equation, and I can solve for W. So I'm going to do that. I'm going to bring that 3 over. So 2W squared minus 5W minus 3 equals 0. And this probably factors, right? So what is that? 2 times 3 is negative 6. Can we think of two numbers that multiply to negative 6 but add up to negative 5? I guess that would be negative 6 and positive 1. So I'll replace this with those two. So 2W squared minus 6W plus 1W minus 3 equals 0. So all I did was I replaced minus 5W with these two terms. And now I'm going to group them like this. It's a little trick. Alright, so what do these two terms have in common? They have a 2, and 2 will go into both of them, and they both have a W. So I can factor that out. When I do, I'm left with W minus 3 plus, what do these have in common? Nothing, but I can factor out a 1, W minus 3. Alright, so what's left now, if you look at this term and this term, what do they have in common? W minus 3, right? So I can factor that out, leaving me with 2W plus 1. Alright, so now I can say, well, if W minus 3 equals 0, then W must be 3. And if 2W plus 1 equals 0, then W must equal negative 1/2 if I solve it. But remember, W is just temporarily replacing S plus 1. This must be equal sign. Right? So I need to replace W back with what it represents, which is S plus 1. So S plus 1 equals 3, and S plus 1 equals negative 1/2. So now I subtract 1, I get S equals 2, and I subtract 1 here, and I get negative 1 1/2, or negative 1.5, I guess. Alright, so I get two solutions, and they both should work. Because there's no radicals, so they seems like they both work. So let me go ahead and graph it and see if in fact they do both work. So 2 parentheses x plus 1 squared minus 5 times x plus 1, and this is 3. Graph. I need to change my window, so I'm going to do zoom 6. And you see there are two solutions. Second trace intersect. I'll go do this one first. Enter, enter, enter. Negative 1.5, which is what we got. And the other one, I'll just check in my table because it's a whole number. So I can just go to my table, and I do get agreement there that they're both 3. So that's also a solution. Alright, let's see, what else? Let me try 60. So x to the 1/2 minus 3x to the 1/4 plus 2 equals 0. Alright, so this is the equation. Again, this is quadratic form. If I let some letter equal that, right, so if I let w, let's say, equal x to the 1/4 power, just temporarily, then w squared, if I square it, well, when you square that, you just multiply the exponent by 2, and that's going to be 1/2 is x to the 1/2, right? So that means I can go ahead and just make it look quadratic for a little while until I get it down to solve for w, and then I'll replace it back with x to the 1/4. So let's see if this works. Alright, so instead of x to the 1/2, I'm going to put in w squared. Minus 3 times, instead of x to the 1/4, I'm going to put in w. Plus 2 equals 0. Alright, this factors to w minus 1, w minus 2, right? Because when you multiply those, you get 2. When you add those, you get negative 3. So therefore, w is 1 and w is 2. Alright, but remember, w equals x to the 1/4. So x to the 1/4 is 1, and x to the 1/4 is 2. Alright, so what do I do to get rid of the 1/4 power? Well, I just raise both sides to the 4th power, right? So when I raise this to the 4th power, I just get x. And when I raise that to the 4th power, 1 to the 4th power is just 1. So x equals 1. Over here, when I raise this to the 4th power, I get x. And when I raise this to the 4th power, I get 16, right? 2 times 2 times 2 times 2, right? So that would be 2 times 2 is 4, times 2 is 8, times 2 is 16. Right? So those should be the solutions. Let's see what this thing looks like if I graph it. So I'm just going to use decimal, same thing. So x raised to the 1/2, same as 0.5, minus 3 raised to the 0.25 plus 2. And then it's equal to 0, so I'll just get rid of that, or just make it 0. Alright. I need to go out further, because one of the is supposed to be 16, so I need to go out to, let's go out to 20. That doesn't seem right at all. Did I put it in right? Oh. X raised to the 0.5 minus 3x raised to 0.25. There we go. I just put it in wrong. Try it again. Barely see it. As you can see, it's really hugging the x-axis, so I need to get rid of all the space and kind of zoom in. So I'm going to change my x maximum to like 1, my x minimum to -1, I guess. So, I mean my y, sorry. My y min is -1, my y max is 1. That should stretch it out vertically a little bit so I can see it a little bit better. Here we go. Alright, so now you can see that it crosses at 1 and it crosses right here at 16. And those are both solutions. Alright, I think that's enough for this video. I'll come back and probably do a part 2 with some more problems. Thanks for watching.